Example 2 is asking us to find out if x minus 1 is a factor of this polynomial. So we know if we use synthetic division and the remainder is 0, then that x minus 1 is going to be a factor. So I have this set up here for synthetic division. So we'll bring down the 4, multiply. And we get 4. So since we get 4 there, this tells us we have a remainder. Therefore, since we have a remainder of 4, x minus 1 is not a factor. If it was a remainder of 0, it would have been, but because it's 4, we do not have a factor there. Okay. So the next one's saying to show that x plus 2 is a factor, and then we're going to find any of the remaining factors, and we're going to also write down what the graph would look like. So I have it set up for synthetic division. That's how you're always going to prove that it is a factor or not. So we're going to bring down the 1 and then go ahead and multiply. All right, so since r is equal to 0, x plus 2 is a factor. Now, what we're going to do is we're going to learn something new called a depressed polynomial. Your depressed polynomial is the result here when you have your factor. So it's going to be 1x to the second minus 4x plus 3. So again, this is our depressed polynomial. So we can use that depressed polynomial to figure out if we have other factors. Can this factor? And this one does nicely. We don't have to do the quadratic formula or complete the square. We can just go ahead and factor that out. So this x minus 1 and x minus 3 tell me where my other x-intercepts will be. So let's look now at the graph. What would the M behavior be? So M behavior, I want to look first, what is that leading coefficient? The leading coefficient was a 1, and it's positive. It's x to the third power, which means it's an odd function. So therefore, it's going to have opposite behavior, and it's going to start down and then go up at the end. So I can say as x approaches negative infinity, your f of x is also approaching negative infinity. As x approaches positive infinity, your f of x is approaching positive infinity. What's the y-intercept? The y-intercept is where x is 0. So if we were to put 0 in for all the x, your y-intercept would be 0, 6. Because when you put 0 in, everything else disappears there. Your x-intercepts, well, what are our factors again? We had the factor that we just proved, x plus 2, and then we factored the depressed polynomial and got x minus 1 and x minus 3. So your x-intercepts are going to be negative 2, 0. And I'm using the zero product property to find that. We have 1, 0, and then 3, 0. The last example on the notes is asking us to find a missing value there, a constant k. We know that x plus 1 is going to divide into this, giving us a remainder of 3. So I have that set up, and that's my unknown k, and I know the remainder is 3. All right, so I'm going to put that in there. So we brought down the 1, we multiply, add, multiply, add, multiply. Normally we would add. So I know that k plus 2 has to equal 3. So what's k equal to? K would be a value of 1. So that is our remainder theorem. If you have a factor of a polynomial, then your remainder will be 0. You can use synthetic substitution instead of evaluating. Whatever you get for your remainder will be whatever f of blank would be. And if you do have a factor, the polynomial that you have remaining would be a depressed polynomial, and then you can factor to find your other roots.